here's the agenda of the talk. First, I'm going to talk about the general blockchain models right now in the industry, and then I'm going to talk about the Stateful UTXO model, a bit overview, and then dive into the technical details. First, I want to introduce why we care about blockchain model. Blockchain is a digital ledger that is distributed in a peer-to-peer network. It's for example, Bitcoin is like probably one of the largest distributed systems in the world. It looks very simple from the very high level, right? It's just a simple ledger, but under the hood, the technical details is very, very complicated. It involves a lot of components to make the system to operate properly for like more than 10 years without a downtime. To make sure that the blockchain can work properly, there are two things we care about at a high level. The first thing is the uniqueness of the blockchain, because the blockchain is running in a like very large scale distributed system, distributed network. Every one of node will keep a copy or somehow a simplified version of the blockchain. We need to make sure that everyone has the same version of the blockchain. And this boils down to the consensus algorithm. It's very, very challenging and complicated when the network size is really huge. Right now, I think there are two types of consensus algorithms that really work for very large scale network, like more than 10K nodes in the network. There are other algorithms like proof PBFT. It's actually pretty hard to scale it to such a scale. So right now, only proof work and proof stake can work in this kind of scale. I personally think like proof of work is more scalable than proof of stake. But today we are not going to dive into this topic. We're going to talk about the second important topic of blockchain. Is the correctness of blockchain. Now assume that the consensus is provided and everyone in the network they get a correct copy of the blockchain. How can we make sure that the full node they can calculate the correct balance of each wallet, right? This is very critical, especially like because the blockchain is source code, right? It's very easy to write bugs in the source code, and we need to make sure that even like we may make some mistakes, we still can easily verify that the blockchain is correct. And this boils down the blockchain model. Blockchain model mainly cares about two things at a very high level. The first thing is how the blockchain is used. It's basically define the domain or the scope of the blockchain. Like Bitcoin is about the balance of the wallet. Ethereum is about applications built on top of the blockchain. And then the second thing, important thing for the blockchain model is how the blockchain can be verified. This is very critical for the correctness. Just like programming language, you have different language, different trade-offs and different assumptions, and you get different features. You get different ecosystems. Like C ecosystem is very different from the Rust ecosystem, right? Or the Haskell ecosystem. Same for blockchain. You have different model, you have different trade-offs, you have different ecosystem like Bitcoin, like Ether, and Solana. Right now there are many two blockchain models in crypto space: the UTXO model and the account model. First, I'd like to talk about UTXO model because it's the first blockchain model. UTXO stands for unspent transaction output. It's for me, it's kind of still very impressed that Bitcoin used this model from the first day. In the UTXO model, each transaction consists of a set of inputs and outputs. where each input is the unspent output from previous transactions, as you can see from the picture on the right side. It's mainly used to track the balance of wallets, and it's also very easy to verify the correctness of the blockchain. First, you just check that there is no double spending. Basically, you check that the input they are valid is not something like you create from air. And then you have the input-output equation, which is pretty much like the double entry bookkeeping system. Here you just check the sum of the balance in the input and make sure that it's equal to the sum of the balance in the output. This rule is very simple to verify, and it provides greater advantage for security. Yeah, so overall is very simple and very secure, and we never see any on-chain hype for Bitcoin system in the past since its launch, right? We the only thing we see is like someone lost his private key, or the private key got stolen. So that's a great advantage of UTXO model. There are some efforts to extend the model to make it more powerful and to support more applications, like the extended UTXO model and the cell model by other projects. On the other hand, we have another popular model. It's called the account model. It's very well known for because it's adopted and make it really popular. So account model is more like the traditional database. The transactions, they can have direct access or direct operation with the database. They can change the value of the states. And for every transaction, they will update the state. And for every block, we will run every transaction and get the final state of the after the execution of the block. It's mainly used for smart contracts nowadays, or building more complicated applications, because it's more powerful, it's more expressive. For the verification side is more complicated because for each transaction you are gonna need to execute the contract code, and you're going to update the states following the execution, following the rules. And for each block, you need to verify that the final state is correct. And because the state can be huge, right, is a blockchain. So the verification is not trivial. Usually we use a Merkle tree to model the contract states, the blockchain states. And for each block, we just check that the root hash of the Merkle tree is equal to the block state hash. To summarize, account model is expressive and very flexible. It's just like you can almost do everything you want, or we say that it's Turing complete. But the job is like it's more vulnerable to attacks. It's flexible, so anything could happen basically. Yeah, I think everyone in the field should be very familiar that we have seen a lot of attacks in the past, and every time we have seen this. Not every time, actually. Many of the times we think this, we say that this bug is stupid. We could avoid it from the beginning if we have done something differently. Yeah. But unfortunately, it's very hard for the ecosystem like Ethereum to migrate to something completely new. Yeah. So I guess still we'll see a lot of hacks. I think actually this week we have seen 5 attacks. Yeah. Somehow like that. Quite a lot this week. Yeah. So here's a short list. It's not complete. It's a short list for the comparison of the account model and the classical UTXO model. first on the pro side, account model is the programming model is more dev friendly. I think a lot of people can learn how to write a smart contract or write a dApp with solidity in hours. It's very expressive and flexible, just like you can do with other programming languages. And the transaction size is relatively smaller compared to UTXO model. And on the UTXO side, the main advantage is, first, the UTXO is directly owned by the users. By this, it means unless someone steals your key, you are going to have full control of your assets. But on the EVM side, the asset is modeled as contract states. For example, the ERC20 is protected by the contract. If there's a bug in the contract, your token might be lost in hikes. So this is a huge advantage. The second advantage is the UTXO model has this explicit input and output model. You can do a lot of verification for due to this specific structure. For example, you check the balance directly, no matter how the transaction is executed with the virtual machine. You could always just verify the balance for the transaction, and this provides great advantage for verification. The third one is about the efficiency of the model. You can parallelize the execution of UTXO easily because the input is immutable. If you spend it, it will disappear from the next block. This is very just like the other programming languages. Like immutability is great for parallel execution. Is great for scalability. So the disadvantage side is also obvious. First, mutable states creates more room for bugs and attacks. We have seen this a lot, and it's hard to execute in parallel. I think there have been several projects try to execute the Ethereum transactions in parallel. There are some ways to improve this, but it's still not as good as the UTXO model. For the UTXO model side is the disadvantages. For the classical UTXO model, you are going to have concurrency issues if you want to apply it for dApps, because you're going to need, for each input, you can only use it once. It means two transactions cannot access the same contract states in parallel if you want to modify it. Yeah. And the last one is UTXO model is relatively less popular for smart contracts. It means if you want to build dApps, you're going to learn about the model. This will take a bit of time. Yeah. So as we have seen that, like, two very different kinds of models, they have pros and cons. The natural question is, can we have the good things from both sides? The answer is definitely yes. Account model is convenient for computation, and the UTXO model is good for securing digital assets. If we combine both, we can get the benefit of both, right? That's why we propose the stateful UTXO model. It's I see it as a smart merge of both. So if you look at the graph below, on the left side is UTXOs. The UTXOs can be owned directly by users, and also contracts, they have assets. So contracts can also own UTXOs. It depends on the model of your application. For some applications, you can just say that the contracts, they don't own the UTXOs, only users own UTXOs. But in a lot of cases, I think contracts will own UTXO. For example, if you want to build a DEX, then you have the liquidity stuff, then the contract will own the quite a lot of the token of the trading pair. On the right side is the contract states. That is purely just some key value stuff. And those states can only be accessed by contracts, and the users they can call smart contracts. Here the different thing with UTXO model is that the classical UTXO model they don't have access to contracts, and the difference from the account model is they don't have this model of the UTXO part. It means they don't have the secure abstraction for digital assets. So here the Stateful UTXO model is at a very high level is combination of both. But under the hood is not easy to do this. There have been a lot of projects trying to kind of do this, but not great success. There are, like, as we all say, that devil is in details, right? So yeah, we managed to find the proper way to put them together, still keep a good user experience and dev experience. So now I'm going to talk about why the Stateful UTXO is great. The first thing is scalability. This is kind of a feature that is kind of inheritance of the UTXO model, because yeah, as we have said before, UTXO model is great for scaling. In our case, we are sharded blockchain. It means we have multiple blockchains running in the network. We combine the Stateful UTXO model with DAG to shard blockchain into multiple chains, and then we can execute the blocks in parallel. So we can achieve higher throughput. One of the great thing about our sharding algorithm is the cross-shard transaction is only requires a single step. So for users, if you want to send some coins from one shard to another shard, you don't feel like there's a sharded blockchain under the hood. You just make the transaction, and then your coin will be in other blockchains in just one step. This is great for developers and also great for users. And then the same thing about the nice thing about Stateful UTXO is programmability. As I have mentioned before, that UTXO is not really easy to support smart contracts. There have been a lot of efforts trying to add this for Bitcoin, I think, but it's still kind of research in progress and work in progress. In our case, we can really provide very good dev experience. We can support very powerful applications. First, token is first-class citizen in Stateful UTXO model, and this is very similar to extended UTXO model. Basically, in the output, not only you can have the built-in coin, you can also have tokens. So it's it's by default supported by the blockchain. Second, contracts they can also have UTXO access, and not only that, they can have mutable states, just like the account model. And the smart contracts they can have access to these states, and the contract code they can model a lot of things with these mutable states. Like for example, if it's Oracle, then you have the state to store the price of the trading pair, something like that. Compared to the classical UTXO model, because we have these mutable states, we don't have the concurrency issues for applications. It means you can submit transactions in parallel to call the same contract without worrying that the input will be invalid. Yeah, and overall, is still our model is still dev friendly. We have been working on SDK, the programming language, for quite a long time already. So far, we feel really confident about the dev experience. And the security advantage of Stateful UTXO model. It's a new paradigm, combines the benefits of both sides. First is input and output paradigm, and this creates a lot of more room for verification for defenses. Yeah, this is like UTXO model. Second thing is also from UTXO model, you have the, by default, the UTXO are controlled by users if it belongs to users. So by default, the asset is very secure, and the contract state is mutable. So here is actually, mutability is usually have some security concerns in general, but in our case, is the trade-off is the assets is always immutable. So assets have very high security by default. And here the mutable contract state is the developers need to take more care of it, like the account model. But I think it's a big step forward compared to the conventional account model, because there you model everything with mutable states, but here is like the most critical part, the digital assets, they are immutable. So I think that's a great trade-off. We also added a lot of security considerations for the contract states. Last, we have built-in asset permission system in the virtual machine. This is very unique in our model. It's something, I think, it's really something we want in the space for DeFi, for dApps. The reason why we don't see this coming out, because a lot of projects, they are like EVM compatible, right? So they have to kind of inherit the technical data of EVM. But we are a brand new blockchain. We built a brand new virtual machine. We have the opportunity to avoid a lot of the design flaws in the EVM ecosystem. Yeah, lastly, I want to mention that actually our virtual machine and our Stateful UTXO model is very efficient and lightweight. We built the wormhole bridge, and the core contract size is 1 KB. On EVM, the contract size, the bytecode size is 10 KB, and on Solana is 1 megabyte, which is huge. We also require less computation, and it's less and also less I/O for the execution of transactions. Yeah, so that's kind of overview of the Stateful UTXO model and the benefits of it. Now I'm going to go a little bit more into the details. Yeah. Once we have this concept of Stateful UTXO model, the very important part is about the execution, basically the virtual machine. We built a brand new virtual machine with a lot of security features to work with our new model. Virtual machine is a very complicated piece of components in blockchain. I think we have seen a lot of like bugs due to the flaws of the virtual machine. So from the very first day we designed the virtual machine, we keep in mind that we try to avoid the existing design flaws, especially EVM. So our virtual machine is a stack-based virtual machine, like Java, like Wasm. Is good for safety. It's is more readable compared to the EVM, and also is more performant. The second part is the virtual machine executes the transaction following the input and output paradigm. This can reduce a lot of issues related to unsafe external core. So if you have done some like smart contract in the past, you should be familiar with that. Unsafe external core is one of the main root cause for a lot of exploits. And in our case, it's going to be greatly mitigated. And the flash loan is not available because of this input and output design. This one is a bit controversial because flash loan can be good, can be bad, but in our design, this is not available by design. I think the benefits is worth it. And the virtual machine has a built-in asset permission system for contract core, and this can also avoid a lot of bugs. Basically, if one function is not does not accept assets, there's no way to exploit it. You call it, you will not benefit from it. You cannot steal the assets of the contract, or you cannot steal the assets of users. So this is also a great feature. And then there are some routine security features, type check, built-in overflow, underflow check. So this is not something big, but it's really good to have for beginners, right? Right now, like Solidity is really easy to learn, but if you want to write very secure dApps, you're going to learn a lot of the good practices. For example, you need to use the safe math library. You're going to be familiar with what is the default value of this of the vector of the map data structure in Solidity. And from what I've seen, like for a lot of very experienced devs, sometimes they still make stupid mistakes. For example, the wormhole bridge hacks in the past. I'm not blaming them for because I think they are very experienced in Solidity, but still sometimes you are too busy with coding, and you are a little bit tired, and sometimes so when you code you forgot something, and then something becomes the weak part of your code. So I think the really great approach is to have all this good practice just built in the system from the first day. The last very different design we make is we don't have low-level support for map data structure. We use server contracts instead. This can mitigate a lot of exploits as well. But it's very technical details, so I'm not going to dive too deep into it. MEV is a very big topic and popular topic right now in the DeFi space. In our case, it's going to be very different from EVM as well. Because the input and output execution model is going to be much harder to have EVM on Alephium, because basically you cannot the MEV searchers, they don't have too much advantages over the users, because you cannot do too many things in one transaction. But on EVM, you basically, if you are attack or if you are MEV searcher, you can do a lot of things in one transaction. You can call a lot of contracts, you can compose a lot of things, and arbitrage like crazy. And this kind of this kind of transactions usually. And this kind of power usually like leads to attacks, like sandwich attacks, front running attacks, or sometimes the attacks is called arbitrage. But in our case, if you want to do this, you are going to do it in multiple transactions. But for normal users, it does not make a difference. It's still, if you want to make a swap transaction, you can still do it, right? In just one transaction. So nothing changes for normal users, but it changes a lot for attacks and arbitrages. I think this is great, right? Yeah, and the flash loan is not available. This can completely change the whole MEV strategy. We also added something called like pseudo random execution of transactions. It means if you submit some transaction, try to extract some value from the contract, there's no guarantee that your transaction will be executed before another contract, because it will be executed randomly somehow. This will also make front running much harder, makes it more kind of fair for normal users. Last, I want to mention that MEV, we don't solve it. It will exist anyway. It's just that it's gonna get much harder, and it's going to be a bit fair, in my opinion, compared to event. Last, I want to talk about our contract language. It's because the virtual machine is different. So we cannot just use Solidity. And also, I personally don't think Solidity is secure enough. So we have to build a new language. And we try to make the language as simple as possible, so it's very easy to learn about it. And also we want to make it to be efficient. So that was mainly the two design goal of the language. It's a domain-specific language. It means it's designed for Alephium blockchain. It's designed for writing dApps specifically. It's not designed to support arbitrary stuff. Yeah, with the language we try to hide the VM details. So, like devs, they don't need to really understand too much about the virtual machine. They can get hands on it, and then they can learn, as they want to build some more complicated stuff. Yeah, and in the language we try to enforce a lot of good coding practices. So if there are something fishy, the compiler will try to warn the users about it. We have the built-in syntax for access permission. As you can see on the right side, we have the annotation called using. It tells the compiler that if this function will use digital assets or not. This is a very good security feature. Yeah, basically on the right side is a simple DEX. It's a few lines. You can see we define the contract, and then we have the annotation to say that the contract will use digital assets, and then we have the function to swap the tokens. And in the body of the function we have some functions to transfer the tokens between the buyers and the contract. So basically this is a kind of the simplified version of Uniswap in a few lines. Yeah, last I want to talk a bit more about the access permission system, because it's one of the very core innovation of our tech stack. You can define if a function they accept access or not. This provides a lot of security guarantees for the function. Second, when you call it, if the function requires to accept the asset, you're going to have to provide it with this syntax. So you can see in the second row, we call the contract with two callers, and the first caller, they provide some coins, and the second one as well. And this will be these assets will be taken by the virtual machine into when the virtual machine executes the function. And if there is no enough balance in the caller, then the virtual machine will exist. So in this case, you can make sure that there will be no someone cannot call or exploit a function without providing the assets. You can also manually approve the assets for more more advanced use cases. Lastly, I want to mention a very important result because of this permission system is the reentrancy is not possible by default in our system because, for example, here if you try to call the same function twice, it will try to use the assets of the contract twice, but it's impossible because you already in the first call the virtual machine already used up the assets of the contract, so you cannot do it for the second time, and this can eliminate a lot of the attacks because reentrancy is really is the root cause of a lot of hacks in the past. So in these slides, I want to say, I want to talk about, we actually mitigate or completely solved a lot of the issues in the EVM ecosystem. So here's a list of the top solidity issues collected by one security agency. The first one is reentrancy, as we have said that it's solved by the input-output paradigm. And then the unchecked external call. So in this case, it's still possible, but we have provided some extra checks in the language, and also in the virtual machine, we will terminate if the function does not exist. But in EVM it's designed differently. And the overpowered owner is this issue is basically like someone has the kind of the the owner permission of the contract, and then the private key got lost, someone steal it, and then someone used the private key to attack the contract. In our case, hacks can still do this, but in a lot of cases they cannot benefit from it because we have the asset permission system, and second is a lot of the UTXOs is owned by the users directly. So even if you are the owner if you become the owner of the smart contract, you cannot steal the funds from users. And the fourth one is the arithmetic precision. This one is actually become less of a problem because the whole industry is growing and the people learn about learn from the experience, and they know how to deal with this problem. But still, it's a tricky case in some cases, tricky problem in some cases. The fifth one is relying on transaction.original. This one is a bit more specific. Very technical detail stuff. I want to skip it. Overflow, underflow. So by default in our virtual machine, we check the bounds of the mathematical operations, so it will not be an issue. And the unsafe type inference, we have the built-in type system. This is not a problem as well. Yeah, so that's all. That's the kind of the more technical depth of the blockchain. Lastly, I want to summarize a bit more about the project. How it started. It was started in the initial idea started in 2017. I was following since 2016. I was following the sharding roadmap of Ethereum, and I was not really happy about this. So I want to build a new sharded blockchain with a new algorithm. Now it has been, I think, quite a few years. I have been working on the project for full time since 2018. The mainnet was launched in 2021, and we have the sharding running in production, while the Ethereum sharding is still research in progress. We have the Stateful UTXO model right now is also in production. Right now we are focusing on the infrastructure stuff. We are working on the SDK. We are building the bridge. We are building some dApps to test the whole stack. And we are going to make a hard fork by the end of this year to add more features to the blockchain, especially the virtual machine. It's necessary for bridge to other blockchains. Virtual machine is very complicated stuff. When we launched the mainnet, we definitely did not have some considerations in mind. For example, the interoperability stuff. So we need a hard fork to add these cool features into it. We have been working hard for this for quite a long time already, but it's going to happen very soon. And right now, I think it's the whole stack is kind of very close to be mature, and SDK is very ready for building the apps. The dev experience is also great right now, but right now it's only doable on testnet and the devnet. But it's very exciting right now. If you are interested, you can check out the wiki or check out our website to give it a try. You can like build a demo dApp in probably 5 minutes following the guides. It's going to be very easy and very friendly for developers. Yeah, so that's all. Let's build. Thank you for listening to.
We have a few minutes for questions if you want questions before the beers or questions with beers in a few minutes.
I have 2 questions. It might be long.
Go on.
Do you have any examples of applications that you think this would be the best blockchain to build on, or useful application? What type of applications do you see on it?
Yeah.
That's number one. Maybe I'll take the floor to ask my 2 questions. That's the first one. What applications would you see on this? And number 2 is, I've heard you say in the past that you see us in a multi-blockchain world because every blockchain is going to have trade-offs, so it's not going to be 1 or 2 blockchains. Can you explain to me why you think, if you look at operating systems in the world, there are several, there are only 3 basically. Why would blockchains why are they different than an operating system? Why are you going to have many different blockchains whereas you only have 2 or 3 main operating systems?
Yeah. So the first one is sorry, I forgot it.
Applications.
What kind of applications?
Applications. Yeah, I think as I have mentioned, we have I think three main advantages. First thing is scalability. This means high throughput and lower gas fee. If we want to go for massive adoption, this is necessary to have. Like Bitcoin is 7 transactions per second, and Ethereum is 14 transactions per second. It's definitely not enough for massive adoption. So if you want to build a higher throughput applications, definitely we are a good choice. And we don't sacrifice decentralization. We are still lightweight enough everyone can run the full nodes. So that's the first part, the scalability. It's a very challenging part, and Ethereum is working on it as well. The second part is good security because of a new model. Right now, we have seen a lot of attacks on the space, right? If you can provide very high security by default, I think it's going to be very cool for long term. It means people can have higher security expectations by default. I think this is very. It's not easy to ask people to migrate from one ecosystem to another ecosystem, but based on our experience in programming language, right, it can happen sometimes if you really design something good enough. For example, Rust add a lot of security to the programming language space, right? It's not really easy to learn Rust, but still, Rust will grow greatly in the past few years because it provides a lot of benefits over the other languages, right? We don't say that. I will go back to this topic for your second question. And last one is proof of work. I think right now, a lot of blockchains, they go for proof of stake. But in my opinion, proof of stake has a lot of issues. It's not really as scalable as a proof of work for a really very large scale distributed system. And also they have some other issues. I think we still need some proof of work blockchains, and we are in that, and we provide very good programmability to it. For example, the Bitcoin community might be interested to try our blockchain because we UTXO based. You can build applications with UTXO model. This is very cool, right? That's the first question. For your second question is for operating system. You say that we only see very few operating systems, but it's a very different because operating system is general purpose system, right? And blockchain is domain specific systems. So you have different trade-offs. For general purpose systems, you don't have trade-offs. You want to support general applications, right? So it's a bit different. I usually compare it with programming language. We have so many programming languages in the space. You first have assembly language and have C, and then you have Java, JavaScript, Haskell, Rust, Scala. A lot of different languages, and it's not easy to build a language as well. It takes many years to develop the language and polish it and to grow the ecosystem, to ask people to try it. It's the same as blockchain, in my opinion. And because of the bridge of blockchain, you can connect to different ecosystems, and they could be interoperability between interoperation between different blockchains, and you can benefit from that. So my personal view is there's no one blockchain can fit in all size. One size can fit all solution in this case. But operating system is different. You can use one operating system for all your use cases. Of course, if you are a developer, it's a bit different. I use Mac, but I still use Linux system for a lot of testing. So I basically use two systems. Sometimes I even have to test it in Windows. But in most of cases, I think for users, in most of cases for users, you just stick to one operating system. But for blockchain, I think it's very different. Different assets provide different features. For example, Bitcoin you can be sure that Bitcoin will exist in 20 years. But for a lot of blockchains, you will not be sure about that. That's why sometimes you may use the other blockchains, but still a lot of cases you will go back to Bitcoin or Ethereum. So I think in the future, really, there will be a multiple blockchain for the very long term. I hope that answers your question.
Yeah, I'm very satisfied with the question, with the answer to the second question, which was the analogy is not the operating system, it's the domain-specific programming language. That I completely satisfied with that answer. And the first part of what application it's good for, basically what I heard was it's good for DeFi because you offer security and scalability and the UTXO model. So the application, the extension of that, from what I see, from what I hear,
it's not limited to that. I mentioned that because right now it's kind of have been proved that DeFi can be is a good use case. But definitely as a platform, we're not limited to that. Anything related to token, you can build on our blockchain. So it's a token-centric platform. Usually like when you. So I'm an engineer. Based on my experience of engineering, is usually when you build a great library, sometimes you don't even know like how people will use it. In a lot of cases, if you build something really great, like the community usually can come up a lot of interesting stuff to use it. This happened a lot in the past in tech.
The mouse a little bit.
Yeah.
Thanks. Just not to sleep. Can I ask, in Ethereum with DeFi, it's very practical to have this composability and to be able to like chain tons of contracts and have like multi-sigs of multi-sigs that participate to some DAO or something very complex like this. How will it work in terms of composability in Alephium with the Stateful UTXO model?
In our case, it's still very composable. It's just that the input-output model makes it. If you deal with assets, you have to follow the sequential input-output model. But you can, if two operations they are parallel to each other, then they can be run in the same transaction. And if some of the operations does not involve digital assets, for example, querying the Oracle, you can do it at any time. You just call the contract, you query the contract state. So this is very composable as well. So in my opinion, this does not sacrifice anything for normal users. It just make it hard for the attackers or for arbitrators, because in that case they need to really to compose crazily inside just one transaction. If they found one opportunity to exploit the contract, they basically compose it crazily to drain the liquidity pool in a lot of cases. But it's not possible in our case. I think it's great in the case that there will be some anomaly, there's some bad behaviors happen on the blockchain.
Cool.
So can I have a question, please?
Sure, please.
Lately, the near blockchain, they are improving the app chain. Have you heard about that?
Yeah. I think a lot of projects have this.
Yeah, sure.
concept.
So when you share about the blockchain and you share about the SDK that is easy for programmer and developer to build the app on that. So may I compare? So is it in the same concept or it different concept? If I misunderstand.
Mm-hmm. It's different. We are building a layer 1 blockchain, so it's more like. So upchain is more domain specific blockchain, I would say.
It's true.
And the layer 1 is more generic blockchain. So conceptually it sounds very beautiful, like you can have upchain for your service, but actually the cost of maintaining and developing the upchain is not easy. Also security side is hard. And also there are some decentralization issues for that. If you are, for example, if your upchain only have several owners, it's not